Okay, so we have a test coming up, a fairly limited amount of material, but just in case you are stuck on anything, you can just fast forward this to find the parts that you want, or just watch it on through as a way to remind yourself how we did all this. So I'm going to talk through the problems that we had. I do think this is helpful for some of you, and so for those that it helps, that's why I'm doing it. Guess this is what math teachers do on the weekends these days. So off we go. Let's take a look at this thing. So one of the concepts we tried to teach you this particular term was how to simplify radicals. And so remember, we kind of likened it to the idea of playing Go Fish. So when I see the number 48, we could break that up as like 2 times 24, but 24 was 2 times 12. 12 was 2 times 6, which is 2 times 3. So if we were to all put that together, that was 2 times 2 times 2 times 2 times 3. It's a whole lot of twos, but I see a pair of twos as well as another pair. And I know some of you would do that as a factor tree, and that's okay. But I had 2 pairs of twos, and I had a 3 left in my hand, so that was 4 roots of 3. Is kind of how we would do that. And keep in mind, if we wanted to double check to see if we did okay on that, the square root of 48 should be exactly the same value as 4 times the square root of 3. And you could do that on any one of our calculators to validate that we did okay. Now, some of you might have picked a slightly different way to do that. Like some of you might have said, well, 48 is 4 times 12, which was in turn 4 times 3. And notice larger pairs was 4 roots of 3. A variety of ways to do that. Now, in question B, we've already kind of broken it down a little bit. And so what jumps into my head is that I see the number 60, which is actually a 5 times a 12. And 12, of course, was 2 times 2 times 3. Again, we've done all of this stuff in class. We did this because sometimes people would see those 2 5s and get confused. But remember, this is kind of already like somebody's already laid those 2 5s down and we're good. So we're just going to go ahead and bring those 2 out. So we still have our 5 that was already part of our story. The 2 comes out. We still have the 5 and the 3 inside. We don't have a pair for those. So putting it all together and expressing it would be 10 roots of 15. And that's going to kind of finish our story. Now, over here, we made reference to the idea that some people would take 27 times 98 and say that this would be 35 square roots of 2,646. But my goodness, that would be a silly way to do this problem. That's filling the hole back in before we start digging it again. It would be silly because I know that 27 is 3 times 3 times 3. Our whole goal is to break it down. So why do something silly by making it so big? And then 98 is 2 times 49, which 49, of course, is a couple of 7s. So I've got a pair of 3s and a pair of 7s. So I've got my 35 from the entry part of the problem with a 3 and a 7, and I still have the 3 and the 2 in my hand right here. The parts that did not have pairs are staying inside this spot. Keep in mind as we do that, the parts inside stay. And so putting it all together, this is a large number, 35 times 3 times 7. It's kind of large, it's 735, and that would be the square root of 6. Now, keep in mind, I don't know about you, but I look at problems like that and I see a lot of potential for mistakes. So I'm going to try something. I'm going to ask my calculator to take 7 roots of 27 times 5 square roots of 98. And let's see how we did. I got 1,800 and change, okay? So according to my calculations, it should be 735 times the square root of 6. And I got the same answer. So that's pretty good. I know that I did at least these 2 problems right. I could have checked that one as well. Okay, number 2 is a quickie. We want to remember that you're going to set each of those things equal to 0. And depending on how good you are at these things, some of us would like to set it equal to 0 independently. This was called the zero product property. Says the only way to get 0 is if each independent piece is 0. And we're going to solve all of those. Now, I know for a fact that many of you could look at this and just jump to that answer really quickly. Or some of you could jump to this answer, but if there's a reason that you cannot see that answer, the process that we would go through to solve that would be Fairly obvious. Bring the 1 across and divide by the 7. So these are the two answers from that one. So notice it was already factored. We kind of set it up for you, so a lot of you could just write the answers down very rapidly. Now for part B, we're going to go ahead and go a little bit different. We're going to look for two numbers whose product is -14 and whose sum is -5. And of course, the numbers 2 and -7 would achieve that feat. And in a very similar way to this problem, I can look at it and see the two answers that would produce a 0. One of them is 7 and the other one is -2. And that's fantastic when we can solve a problem that fast just by looking. Now, of course, this one is set ready to go for this idea of solving by roots. This is a perfect square. So if I were to choose to take the square root of both sides, I would just have plus or minus root 12 over here. And we should, of course, break up 12. And we've seen that one earlier, I think, up here. There was a 12 in that story. But that's 2 roots of 3. That's plus or minus 2 square roots of 3, because keep in mind we had our pair of 2's. And so if we were to subtract 3 from both sides, we usually put the 3 in front because this root part, we kind of put the ugly part at the end. So -3 plus or minus 2 roots of 3. That's not too hard to do. Now, moving on a little bit further, number 3, the process that we have done in class, and I think that's not just for my class, but also Mr. Wheeler's, is we tend to, when doing specifically completing the square, we like to go ahead and move that number over so we know exactly what to go here. So we know that if we cut this thing in half, we're going to get the number 4. And that's going to be my completed square. But there was a problem because remember, it wasn't just cut in half, it was cut in half and square. And in this case, cut in half and square leads us to the number 16, which is going to be a total of 25. Now, this is very similar to this previous problem over here, and we're going to take the square root of both sides. And we're going to get that not just 5, but we're going to get a plus or -5. So with a little bit of subtraction, that leads us to our final answer. That +5 take away 4 is 1, and -5 take away 4 is -9. Now, this is our part 1 test, so some of the problems that we're going to do on the next test are not going to be rigged up to be so pretty, because I know that some of you would have said, Mr. Penner, that's silly. I would have rather done this and come up with those same numbers in a half the time. And you're right, but we wanted to do one problem so you practice the skill where the actual execution is a little easier. Okay, now with the quadratic, I noticed in class that a couple of you caught it. This is really new material, so we haven't practiced it much, but our formula says take opposite b plus or minus the square root of b squared minus 4ac over 2a. And you can sing a song or dance a jig or however you try to remember that, but that's an important one to remember. But it only solves problems that look like ax squared plus bx plus c is 0. And that is exactly what this problem looks like. However, before I do that problem, I want to do something a little bit tricky. I notice that every single one of these things is divisible by 2. So I'm going to divide by 2 here, 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 and here, which is going to make my a value 1, my b value -10, and my c value 9. Now, yet again, we did something to be kind to you. This problem factors to x minus 9, x minus 1. So before I do the problem by the quadratic formula, I already know what answers I should get. We did this on purpose because this is new to many of you, so it sometimes helps to kind of have a little bit of a knowledge of what I'm looking for to make sure I don't make any mistakes. So let's go. So x equals the opposite of b, that would be 10. We're going to do b squared, which is 100, of course. 10 squared is 100, minus 4 times a times c. Well, 4 times 1 times 9 is 36, all over 2a. Well, we had something very nice occur here because 100 take away 36 is 64. And the square root of 64, well, 64 is a perfect square. So the square root of 64 is the number 8. And here we go. We're ready to go. What is 10 plus 8 or 18? But 18 over 2 is, in fact, the number 9. And 10 take away 8 is 2. And 2 divided by 2 is 1. And we got exactly the same answers we got. Now, whether it'll happen quite that nicely on the test, I guess we'll have to wait and see, but we tried to make the problems very nice for you. Okay, so let's cruise on to the next page. Number 4. I'm going to have this as just one single video. You can fast forward wherever you want to be on it. So we are going to factor. So keep in mind you want to watch, right? We have multiple skills we want you guys to know. So I'm going to do x minus 4x plus 2 because I need two numbers that multiply to -8 that add to -2. So there we go. So we have it. We found the x-intercepts, which would happen at 4, 0 and -2, 0. Notice the two roots that we would get from that, because the x-intercepts happen when you set the problem equal to 0. That's how we find our x-intercepts. Some people will call those the roots. I'm going to go down here and put those dots on my graph. There's the 4 and there's the -2. Now it says, let's find the location of the axis of symmetry for this thing and its vertex. So what I see is right in the middle of the number 4 and -2 is the number 1. Add them together and divide by 2. 4 plus -2. That's going to give me an axis of symmetry at x equals 1. Now, again, on the graph, we can put in a dotted line at x equals 1. Now, it is kind of important that we make that dotted, not a solid line, because the axis of symmetry is structurally there to help us. Now, I want to plug that 1 back into the original problem to find out what the value of that vertex is. So I'm going to find the y value if I plug in 1. And you can either plug it into the original problem, which we talked about, or you can plug it into this factored form. But I think this is easier because 1 minus 4 is -3, and 1 plus 2 is +3. And that's amazing because it shows us that opposites that we've talked about. So the vertex is the coordinate 1 and -9. That's way down here. And then the last thing that we have to look at is what the heck is our pattern? And our pattern, remember 1, 3, 5 gets multiplied by the a value. But since our a value in this case was 1, then my pattern is 1, 3, 5, and we're good to go. So we're just going to count over 1, up 1, over 1, up 1, 2, 3. And hopefully 1, 2, 3, 4. What do you know? It worked. We got it. And we can also see, lastly, that according to my graph, this crosses the y-axis at -8. And of course, we see confirmation of that value right here happening at -8. Now, for number 5, we did decide to make things a little bit less pleasant. It's not as obvious to do. So we're going to use the slightly more sophisticated way using opposite b over 2a. Now, you might remember that quadratic formula. That's actually sitting in there. That's the same values. So remember, a was -3, b was 12, and I'm going to go ahead and write down c for good measure, although we don't really need it, other than we can go ahead and put the number -4 right here on the graph because c is always that y-intercept. Okay, moving back down here. So opposite b would be -12, 2a would be -6, and that makes my axis of symmetry x equals 2. Okay, well, that's kind of nice. Let's put that dotted line in here. And for good habits, I always write what the actual name of that line is. I don't just put a dotted and call it good. I name it, okay? That's good habits for later math classes. Now, I want to find out what happens if I plug that number 2 in. So let's see, y of 2. There was another little pattern that we saw in here. So there's -3x squared plus 12x minus 4. We're going to plug in the number 2 that we got from our axis of symmetry value. Remember, this is the value. Whatever we got, we're going to plug it in wherever the x was. And so as such, order of operations says square first and then multiply. And you should recall that something nice is happening. Remember that little 2-to-1 ratio I have right here. So negative 12 plus 24 is 12, and 12 minus 4 is 8. So when I plugged in the number 2, what I got out of the question was 8. So over here, 2 comma 8, and then my pattern is not 1, 3, 5, 7. This pattern was multiplied by the negative 3 that was sitting in front. It was our A value. So it's now going to be down 3, down 9, down 15. And of course, we're never going to hit negative 21, but let's see what we get. Over 1, down 1, 2, 3. Over 1, down 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we are. And that's cool because we can see that what we estimated worked quite well, because not what we estimated, what we calculated is that y-intercept hit just perfectly, although my curve didn't quite match. And then our final page, the fun final page, is what happens when we go the other way and someone actually gives us what the graph looks like and we want to come and figure it out. Well, there's something that I did tell you in this problem. And that is, it says, let's just find the equation, but it doesn't say what kind of equation. So it could be in standard or factored form. So in this particular problem, what I would do is I would look and see that I was handed the x-intercepts of -5 and of -1. And I already have the values. That's pretty slick. That was very, very fast. But then I can look over here and see that it went over 1, but it went up 1, 2, 3. So that was a very, very fast way to find the value of that equation. Now keep in mind that's in factored form. If you wanted it in standard form, we can multiply that out, which I'll go ahead and do. So x times x is x squared. Then I've got an x and a 5x makes 6x and a 5. So if we were going to write that in standard form, I have 3x squared, I have 18x's, and 15. And you'll notice that y-intercept being 15 is really high up, which is kind of why you couldn't see the y-intercept. Some of you probably were looking for that when you did this problem. Now, when we look at letter B, something bad happens. You'll notice these two values are not easy to see, are they? I can't tell where it crosses the x-axis. So factoring doesn't help me. I don't have these nice, easy values. So we're going to go with the other version. I can see right off the bat that my A value is going to be -2 because it goes over 1 and down 2. So when I look at ax squared plus bx plus c, I know immediately that A is -2. I can also tell from the graph that the C value is +2. The only thing I don't know is what is this B value right here? But there is a little bit of a hint in this problem. You can look at the graph and see that the axis of symmetry is at x equals 2. That is very easy to tell. And remember, the formula for the axis of symmetry says find x, which is opposite b over 2a. Now again, if our answer is the number 2, and I already found out that A was -2. There we have it. Remember, 2 times -2 is -4. Oh, I noticed that these two negatives cancel to make a positive. And so something divided by 4 is 2, and that something better be the number 8. And so now I have my equation of my parabola. And last thing, number 7, we'll finish this off. Instead of having a visual table, we'll just take a look at the data and see what we can have. But you're going to notice it's going to have some very strong characteristics like number 6. So right off the bat, you're going to notice that the number 3 yields the number 0, as does the number -1. So that tells me right off the bat that I could factor that and say x plus 3 would yield a 0 and x plus 1 would yield a 0. And then all that's left to do is to identify where the vertex is, which again has to be right in the middle of those two. Right in the middle. Remember, the vertex is right in the middle of those roots. And I am going to look for my pattern, and it went up 4, and then it went up 12, and then it went up 20, and then it went up more. So in terms of my 1, 3, 5 pattern, I hope that you can see that that 1, 3, 5 pattern kept progressively being multiplied by 4. Again, good numbers. This is fine. I love that answer. But if you were to take the time to multiply that out, you'd get 4x squared, you'd get a 16x, and you would get a 12. And I bring that up in part because notice right here, 0 gives me 12. I could see that. So there's some other ways that we could transfer from factored form to standard. And then last but not least, when we look at this problem, I don't have any zeros listed. That's a little bit unfortunate, but I can watch very carefully that there's a repeat in the pattern that appears to be centered around this value right here, doesn't it? It seems that it goes down by 1, then down by 3, down by 5, and down by 7. So it appears that my 1, 3, 5 pattern has been multiplied by -1. I can also see right here a pretty significant value that when I plug in 0, I get 1, and that's my C value. So kind of similar to this problem up here, I know that A is -1. I'm not sure what B is yet, but I can tell that C is +1. So we're almost there because my axis of symmetry opposite B over 2A is supposed to be equal to this x value right here. That's my axis of symmetry right here. And I already found out that A was -1. So if I cross multiply, I would get the opposite of B is actually +6, which makes B -6. And that, ladies and gentlemen, finishes our little quiz review for the test that's coming up. And I hope that helps you. And I will end up seeing you back in class soon. Bye-bye.